Hello everyone, I hope you are doing well today. So today for this new live, I would like to talk a bit about fractional reserve banking. So I'm not going to summarize the entire topic, but instead I would like to share with you one example, one application that I have created to illustrate this concept of fractional reserve banking, and in particular to illustrate the concept of the money multiplier, to illustrate how commercial banks create money out of thin air. And the example that I have created is based on the South Park cartoon. So here we go. Let's try to use this cartoon and the characters of this cartoon to show how money can be created by commercial banks in a fractional reserve banking system. So the first character that we have is Stan, and Stan finds $100 in the street on his way to school. So the first thing that we should tell or mention is that this bill is part of the money supply. Remember that cash is a component of the money supply. By money supply, I mean M1, which is the most common measurement of the money supply. So it's part of M1, it's part of the money supply, okay? And because Stan is a very smart boy, what he's going to do is he's not going to spend this money. Instead, he's going to deposit those $100 to South Park Hello Bank. So he has a checking account at this bank, and he's just going to convert the bill into a demand deposit. That's it. Okay, so Stan no longer has the bill, it's the bank that has the bill in reserve, and instead the bank is going to add $100 on Stan's checking account. Okay, what's going to happen next? You know that in a fractional reserve banking system, commercial banks must keep a fraction of all demand deposits in reserve. And the typical reserve ratio, or the required reserve ratio, is usually 10%. That's the example that we usually use, but it could be anything, okay? But let's just assume it's 10%, so commercial banks have to keep at least 10% of any demand deposit. Which means that in our case, Stan has deposited $100, which means that the South Park Hello Bank must keep at least $10 as required reserves. And the remaining $90 will be part of what we call excess reserve. So the total bank reserves are equal to the required reserve and the excess reserve. Okay? $90 of excess reserves. And what will this bank, what will South Park Hello Bank do with this excess reserve? It's going to use it to make additional loans. So of course we need to find someone who wants to borrow money. And guess what? We have someone. We have Kyle, and he wants to borrow money from South Park Hello Bank. So South Park Hello Bank will lend $90 of excess reserves to Kyle. And usually when you borrow money, it's because you want to buy something. So Kyle is going to use the $90 that he has borrowed from South Park Hello Bank to buy Kenny's Marvel collection. Why not? Okay, so it's a transfer of money from Kyle to Kenny. And same thing, Kenny is a very smart boy. And even though he usually doesn't have a very long life expectancy in this cartoon, is going to save. He's going to take this money to his bank. So just for simplicity, let's just imagine that it's a different bank, but it could be the same as Stan's bank. It doesn't matter. But okay, let's call that South Park OMG Bank. And Kenny is going to deposit those $90. And same thing, is going to transform that into a demand deposit. Okay. Same thing. South Park OMG Bank must keep 10% as required reserve, so that's going to be $9, and the remaining $91 are going to be part of excess reserves, which means that South Park OMG Bank now has some money available to be lent out. Same thing, we need to find someone who's going to be willing to borrow money, and we are lucky, we have someone else. We have Cartman is willing to borrow $81 from South Park OMG Bank. Okay, so all the excess reserves are going to be lent out to Cartman. And same thing, Cartman has borrowed money because he wanted to buy something, and let's just say that he uses this $81 to purchase Butters' Trapper Keeper. So again, there is a transfer of money between Cartman and Butters. And as always, again, this is an assumption that we make. Butters is simply going to save this money to his bank. So his bank is South Park Nice Bank. So he's going to take this $81 and he's going to deposit this amount of money into his checking account. And same thing, South Park Nice Bank has to keep 10% as required reserve, so it's going to be $8.1, and the remaining $72.9 will be part of South Park Nice Bank's excess reserves, which is money that is available to make additional loans. Okay, and as you can imagine, we could continue forever like this, and the amount of additional loan will always decrease by 10% from 90 to 81 to 72.9, but this would be very long if we wanted to do that until the end. Of course, there is no end actually. This would be an infinite sum. So let's stop here for a second. And let's just wonder what has happened to the money supply. Let's have a look at the money supply. So initially, was this initial bill, right? The cash that Stan found on the ground, which is no longer in circulation, because this bill that Stan found on the ground is now held by the commercial bank as a reserve. And remember that the cash that is held in reserve is not part of the money supply. It's not part of currency in circulation, which is actually, it's quite interesting to think about it, because, for example, the cash that you have in an ATM, it's not part of the money supply, because it's not in circulation. But as soon as you withdraw cash from an ATM, it becomes in circulation, and therefore it becomes part of the money supply. Careful, this does not mean that when you withdraw money, you increase the money supply, because at the same time, when you withdraw cash, the amount of money that you have on your demand deposits decrease by the identical amount. So when you withdraw cash, this doesn't have any influence on the money supply. It only affects the types of money, or the way the money supply is composed between cash and demand deposits. All right, so this bill that was on the ground is no longer part of the money supply. So the money supply decreases by $100. But at the same time, simultaneously, when Stan has deposited this bill at his bank, South Park Hello Bank, then now Stan has $100 extra on his checking account. Okay, so which means that initially Stan's operation had no impact on the money supply. The cash in circulation decreases by $100, but the amount of demand deposits, which is also part of the money supply, increases by $100. So the money supply remains constant. And you know that because it's only when banks make loans, additional loans, that the money supply is going to increase. Okay. Now, let's see what's next. Remember, so Stan brought the money to his bank. Then his bank, South Park Hello Bank, had excess reserves, and South Park Hello Bank made a new loan to Kyle, and then Kyle used this money to purchase Kenny's Marvel collection, and then Kenny brought the amount to his bank. So the second stage is Kenny has received $90 from Kyle and has deposited this amount at his bank, which was the South Park OMG Bank. Okay, so now Kenny has more money than before. He has $90 extra, which is an increase in the money supply. Initially, he didn't have this money, now he does. Not as cash, but as a demand deposit. Okay, so Kenny has $90 extra on his checking account. And then what happened, we had, so now South Park, OMG Bank had excess reserves, were able to make an additional loan to Cartman. Then Cartman purchased Butters' Trapa and then Butters deposited the $81 at his bank. The same thing, the amount of money that is held by Butters has increased by $81, which is, again, an increase in the money supply. So the main point here is that when Stan has deposited money into his bank, this had no impact on the money supply. But as soon as the bank, South Park Hello Bank, has made a loan of $90 to Kyle, this has increased the money supply by $90. And as soon as South Park, which one was it? OMG Bank has made an $81 loan to Cartman, this has increased the money supply by $81. So the idea is that the change in the money supply is given by, so minus 100, this is the destruction of currency in circulation, plus 100, this is the increase in demand deposits in Stan's bank, plus $90, this is the increase in demand deposits on Kenny's checking account, plus $81, this is the increase in demand deposits on Butters' account. So you see that the initial increase in excess reserves has led to a greater than proportionate increase in the money supply. So basically, or let's put it differently, the initial increase in demand deposits, let's put it this way, the initial increase in demand deposits, which was $100, has led to an increase in the money supply equal to $171 when I add all that, okay? $90 plus $81. And this process could continue, okay, because we stopped after only 3 steps or even just 2 steps, but this would continue forever and ever. And if we continued, so the change in money supply would be given by this formula. So this is the currency in circulation being destroyed. This is the initial increase in Stan's demand deposit. Then this is the initial increase in Kenny's demand deposit. This is the next increase in Butters' demand deposit, and so on and so on. And you see that every time when you move from 100 to 90 to 81, every time you basically multiply by 0.9. 0.9, which is 1 minus the required reserve ratio. The required reserve ratio is 0.1. And for those who are into mathematics, you would recognize that this is a geometric series where you multiply each term by 0.9. Okay, you have a ratio of 0.9. And we know how to calculate the infinite sum of a geometric series. It's simply equal to the initial term multiplied by 1 divided by 1 minus the ratio, which is 0.9. So this way we can determine what is going to be the initial, the final change in the money supply. And this ratio, okay, so that's the initial change in excess reserves. And if you multiply it by the money multiplier, okay, the money multiplier is 1 divided by the required reserve ratio. Required reserve ratio is 10%. So 1 divided by 10% is the money multiplier. If you multiply it by the initial change in excess reserve, and this is where we have to be very careful. If you want to find out what's going to be the final change in the money supply, the money multiplier has to multiply the initial change in excess reserves and not the initial change in demand deposits. Remember, the initial change in demand deposits is $100. Okay, but the initial change in demand deposit does not create money. So instead, we have to multiply the money multiplier, or like 1 over the reserve requirement, by the initial change in excess reserve, which was $90. And when you do that, you get $900, which basically tells you that when Stan has increased his demand deposits by $100, this will eventually, through this process of additional loans made by several banks, this will eventually lead to a final change of the money supply of $900. Okay, so let me just emphasize this formula, because I I did find it quite difficult in textbook to find the right formula. Perhaps I can go back a bit before this example to illustrate it. Okay. Yeah, this is how you can find, can put it this way. This is how you can put it. The money multiplier is the final change in money supply divided by the initial change in excess reserve. I think this is the clearest possible definition of the money multiplier. So if, for example, the initial change in excess reserves is $900, as in our example, the final change of the money supply is $900, then you would say that the money multiplier is equal to 10. Okay, and the money multiplier, you know that there is another way you can write it. It's equal to 1 divided by the reserve ratio. Usually, because we make the assumption that banks, they always lend all their excess reserve, the actual reserve ratio is the same as the required reserve ratio. So sometimes in textbooks, it's not always clear. Sometimes they tell you that the money multiplier is 1 over the required reserve ratio. Sometimes they tell you it's 1 over the reserve ratio. Generally speaking, it's 1 over the reserve ratio. Okay. But if banks, they always lend out all their excess reserve, then this is equivalent because the reserve ratio is equal to the required reserve ratio. Okay, well, I think that's about it. I don't have anything else to say about this topic, which is extremely important, especially for the AP curriculum, AP macroeconomics, and which I find very interesting, especially when you ask the students who creates money. Many of them will tell you the government or even the central bank. But I think it's very important for every student learning economics to really understand this process, to understand that this is through this process of making loans that commercial banks will effectively create money. Because if you don't understand that, you can't understand monetary policy. Because monetary policy is all about influencing the amount of money that banks, commercial banks, can lend out. So you need to understand this process of fractional reserve banking, and of course the idea behind the money multiplier. All right, I think that's all for today. Thank you very much, everyone, and I'll talk to you soon. Bye bye.